Hi guys, welcome back to our channel. Today we're going to talk about gas and how it works in our body. Have you ever wondered why we inhale oxygen but exhale carbon dioxide? Our body needs energy to function properly. This energy is produced through a process called cellular respiration. In this process, the oxygen we breathe in helps our cell break down sugar from the food we eat to produce energy. During this process, carbon dioxide is produced as a waste product. Our blood carries this carbon dioxide back to the lungs where we exhale it out of the body. And so, we breathe out the carbon dioxide exhaust in order to make room for the oxygen. Hey, why can I smell your perfume from here, even though you're across the room?
That's what you call diffusion. The molecules inside the perfume container are in a liquid state and stack closely together. However, when you spray them out, they change from a liquid to a gaseous state in a crowd at the nasal tip. Then these molecules travel to the spaces in the air, moving from this crowded space over to the empty space where you are standing.
So, why can I smell it as soon as you pass the nozzle?
Although you won't be able to smell them right away from where you are standing in the room, these molecules will eventually reach you as they spread out in this space.
I see. That's why. Thanks.
1 hour later.
Hey Earl,
Oh, what's up?
you might not feel it, but did you know that there are constant, invisible force that pressing you down?
Really? I don't believe it because why can't I feel it?
Oh, it's true. It is because your body is in a state of equilibrium with the environment. The air, fluids, and the blood inside your body are in a some pressure at the air outside. Your lungs, your blood vessel, and your stomach cavity act like a filled balloon, providing an outward pressure that perfectly cancels out the inward pressure of the atmosphere.
Now I see. Thank you.
Meanwhile,
Kuya, kuya! You know, I have a balloon. You know that balloon has three? What will happen if I inhale too much of the helium? Well, inflating helium will cause your body to temporarily become high pitch. This is usually helium allowing some waves to travel faster in comparison to air. Hey, that's dangerous.
Of course, it's dangerous if you inhale too much helium. Helium is not toxic, but it is an inert gas that contains no oxygen. So, by replacing oxygen in your lungs, it will cause oxygen starvation.
a few inches later.
What's your plan tomorrow for our camping?
Guys, what are you doing?
We're planning for our camping tomorrow. We would like to roast a marshmallow. You want to join?
Sure, let's do it. But did you know that we can use butane for camping stoves?
For real? How can you say so? Do you have scientific evidence about it?
Legit. Well, according to Bartlett M, it provides a consistent flame that is easy to control and is a highly portable and energy efficient hydrocarbon that burns cleanly, producing a consistent blue flame with minimal odor or smoke.
Promise?
Promise!
2 hours later.
Class, kindly choose 3 different types of gases for experiment between carbon dioxide, oxygen,
Sir, what is argon?
Oh well, early you may answer a question.
Jamala, did you know that argon gas is used in some light bulbs to make them last longer?
Really? How do you think so? Can you prove it to me?
Of course, argon has filament. It wouldn't react easily.
Are you sure?
Yes, that's why there are other light bulbs that take a long time to run out. Because argon is inert gas, meaning it won't react easily with other elements. Also, argon helps protect the thin metal filament inside the bulb. If oxygen were inside the bulb, the filament would break.
The first part, investigation. Okay, before the experiment, did you bring your materials with you?
Of course! How about you?
Of course.
About you?
Okay, I will give you 5 minutes to get ready to prepare your experiment.
I wonder what will happen if you cover a candle with a glass jar.
Wait, we can do that for a science experiment.
Janelle, we didn't purchase a candle. Let's do the experiment now. Oh, okay.
Now that we have a candle, let's light it.
Next, we'll need a glass jar to cover the candle.
Yeah, I have one right here. Here you go.
Thanks. Here you go, Jack. Can you demonstrate?
Now that I've got the jar, let's proceed to the next step. We'll need to cover the candle just like this.
So, what will happen now since it's covered?
Look, it's disappearing.
Keratin? Keratin?
As you can see, the candle will lose its flame since the pressure of the handle drops down because the flame quickly heats the air, causing it to expand and escape, followed by the cooling and contraction of the remaining air after the flame exhausts the oxygen. Now, we need to do another experiment for carbon dioxide.
Okay, let's do that.
Let's get the materials. Let's go.
Should we begin doing the experiment now?
Of course, but we need soft drinks and baking soda for this experiment.
Oh, so what do we do now that we have the materials?
Of course, we need to wear a face mask because we will do an experiment.
Alright.
Here you go. Here you go. And for you.
Thank you.
Now, what about our materials?
Here. The baking soda, the soft drinks, and the face mask.
Alright, that's all. Let's move on.
Okay.
1 million zillion jillion dillion cotillion times later. One eternity later.
Now that we're done with the experiment, could I ask a question first?
Of course. Go.
Why did it explode then? And can you explain how it happened?
Well, it causes a rapid chemical reaction that produces a sudden violent eruption of foam and bubbles. The baking soda reacts with the acid in the soda. That's why it creates a massive amount of carbon dioxide gas, which can cause the bottle to overflow.
Okay, now that we're done doing the experiment, let's ready yourselves for the presentation tomorrow. Janelle, Gwyn, Earl, you will present the experiment tomorrow. Let's clean up and go home after.
Alright. Good afternoon. We are Marigold. Okay, now that we've seen science in action through different parts of our daily lives, it is crucial that we actually understand the why and hows with these behaviors. Knowing this theory helps us see that these aren't just random events, but follow specific laws of nature.
Gas exhibit has a very low density because the particles are so far apart. They possess much higher kinetic energy compared to the solids and to the liquids. This energy is what keeps them constantly moving and bouncing around at a high speed.
Wait, why do gases have higher energy?
Oh, good question. Because gases can change shape because their particles have more freedom of movement compared to the solids and to the liquids.
This demonstrates how gases, even those we can't see, occupies its space and have a direct effect on physical reactions. It proves a very important point. Just because something is invisible, it doesn't mean it has zero mass or doesn't exist.
Thank you. That's our presentation.
Now that we have a better understanding of how gas particles behave, we can now understand that every single of these particles is in a state of constant, rapid motion. As these billions of particles fly around, they are constantly colliding with one another in every surface they touch. The force generated by this collision is that we define as atmospheric pressure.
To understand this better, we look at real and ideal gases. An ideal gas is a simple model scientists use to make math and calculation easier. It assumes particles always follow the gas laws and never interfere with each other.
So what is gas really? Most people assume that it doesn't exist because it's an empty space, which is just a misconception.
Well, gas is actually straightforward. Like solids and liquids, gas is a state of matter. Hence, it has mass, so it has weight, and it has volume, so it occupies space.
You could look at the kinetic molecular theory to understand how it works. It tells us that gases are in constant random motion. With its high energy, gases spread out to fill the entire shape and the size of the container.
That's right, because there are many empty spaces in between the particles. Gas is very compressible. This means that the large amounts of gas can be forced together into small space. An example would be the high-pressure tanks used for medical oxygens or even the LPG tanks in our kitchens.
So in summary, gas is something that has weight and takes up space even if you can't see it, and is made of tiny particles constantly moving in random motion. This movement is what creates pressure and allows us to squeeze gas from containers. Simply put, gas isn't nothing. It is a very active form of matter.
Exactly.